I think you must hear a little bit about dark matter. What it is, how physicists got this idea of this kind of matter. That's not so simple stuff to think about it. If you're interested in this topic, keep watching it. According to the modern assumptions of cosmology, today there are 4.6% of ordinary matter that we can see, and 23% of dark matter, and rest of 72% of dark energy is present in this universe. And cosmologists also believe that 13.7 billion years ago, universe was dominated by dark matter. Although dark matter and ordinary matter are matter, but they don't behave in the same way. In the early universe, ordinary matter was mainly ionized and partially interact with radiation that is called Thomson scattering, elastic scattering of electromagnetic radiation by charged particles. Now, you can ask me that why dark matter is called dark? Because it doesn't appear to interact with electromagnetic field means it doesn't absorb, reflect or emit electromagnetic radiation, and so it's difficult to detect. Most of the experts think that dark matter is abundant in the universe and that it has a strong influence on its structure and evolution. Various cosmological observation tells us about the dark matter. Several of evidence include observation in gravitational lensing and the cosmic microwave background, along with these astronomical observations of observable universe current structure, the formation and evolution of galaxies, mass scattering during galactic collisions, and motion of the galaxies within galaxy clusters, but we can't even see or detect this kind of matter. Now you can ask, if we can't even see this object, how can I pose this idea of this dark matter? You're gonna be say that how physicists are saying something without any evidence, so much confidently, and something else. Then wait a minute. Let me begin with the simplest one. The spiral arms of the galaxies rotates around its galactic center. From various real cosmological observations, we have come to the conclusion that there should be much more matter to hold the shape of the stars and planets of the galaxies that are mostly present in the spiral shape, and even our own galaxy Milky Way. From the mathematical observation, orbits of stars in outermost parts of the galaxies can be able to stabilize their orbits by only gravitational attraction of total mass present in the galaxy. As far as we know from the Keplers Second Law, the areas swept out by the orbital radius are the same per equal time intervals, where capital L is the angular momentum and mu is the reduced mass of the system and capital A is the area swept out by the radial vector. According to this law, circular velocities of stars in the outermost part of the galaxy should be lower than the innermost part of the galaxy, like our own solar system. In the 1970s, when astronomers observed the galaxy NGC 3198, a typical spiral galaxy, they found a discrepancy between the observed data and theoretical data from the graph of circular velocity around the galaxy of the stars versus distances of the stars from the galaxy center of NGC 3198 is shown by the red dotted line of the curve, and the solid line shows the curve according to that Keplers Second Law. We don't observe very much difference of the velocities of the outer part of the galaxy in reality. This discrepancy indicates there should be much more matter that is invisible is present in the outer parts of the galaxies to hold it. So, if you will tell that all the invisible stuff, mainly dark matter, is present far away from the center of the galaxy, then you will right now. Some of the cosmologists believe that as the central part of the galaxy is filled with ordinary baryonic matter, then most of the dark matter should be present in the outer parts of the galaxies, where the density of the ordinary matter is very low to consider. In the late 1980s, it was usually assumed that the dark matter was ordinary matter comprised of protons, neutrons, and electrons in some not fairly detectable form, perhaps gas clouds or massive compact halo objects, MACOs. like white dwarfs or neutron stars, or even black holes. However, recent started formation of galaxies has led cosmologists to believe that a significant fraction of dark matter must be different from ordinary matter. Perhaps it arises from the masses of the very light elementary particles such as axions, very light elementary particles, or neutrinos. It may even consist of more exotic species of particles such as WIMPs, weakly interacting massive particles, that are predicted by modern theories of elementary particles but have not yet been detected experimentally. The only property we know about it is non-baronic in nature and doesn't interact with ordinary matter except through gravity. But missing mass could also be evidence of the existence of a shadowy world with matter in it. The shadow world means that can be consist of dark stars and dark galaxies made with the dark matter. We can't see these dark galaxies or stars because light can't propagate in higher dimensions, but gravity can. So the ordinary matter like us only observes the four-dimensional world, can't see this dark world in extra dimensions, but scientists are still working on dark matter, and various observations were undertaken but failed, and some are still going on. I think we have a little bit known about the dark matter and its properties. Even this, we can't even see this. I will see you in the next episode with a new interesting topics of physics. If you like this video, smash the subscribe button and give a thumbs up. Until then, try to think yourself in a high dimensional dark world.